everyone. Today, we will introduce how to use Touch Key Development Tool. We will take the M258 series chip as an example to explain. Of course, it is also applicable to other series of chips. Engineers who use touch keys know that touch keys need to be calibrated before they can be used. In order to make touch key development more convenient and efficient, Nuvoton provides a GUI tool called Touch View for user to develop their touch key system. It can not only set the touch key pin, sensing time, sensitivity, and other parameters, but also calibrate the touch key, generate calibration parameters, and then export the calibration parameters. It is directly applied to the application project. Finally, it can also quickly confirm the performance of the touch key. Let's take a look at the agenda first. Today's content will be introduced in 6 parts. The first part introduces the development tool of touch key. The second part introduces how to build the calibration environment. The third part introduces how to configure parameters. The fourth part introduces how to calibrate touch key. The fifth part introduces how to export calibration parameters from the Touch Key Development Tool. Part 6 introduces how to use Touch Key Development Tool to confirm key performance. First, let's take a look at the functions of the Touch Key Development Tool. Nuvoton's Touch Key Development Tool is called Touch View. You can see the picture on the right. Its main functions are to configure the parameters for touch key system, calibrate the touch key, export the calibration parameters, and confirm touch key performance. As you can see from the picture below, the software is saved in the M251 BSP/tool/TK directory. Next, we need to build a touch key calibration environment. First of all, we need to prepare the resources. In addition to preparing the development board, we also need to obtain the M251 BSP and development board resources from the above website. Then we need to set up the development board. There is a new link to me on the development board. You need to change new link to me virtual COM switch number 1 and 2 to on. Virtual COM is used to communicate with Touch View. The development board is connected to the PC via a new link to me. We also need to program calibration programs to the development board. Find the corresponding example under M251 BSP and open it with Keel. Then compile and program the calibration program according to the steps in the figure. Note that the project you need to select at this time is the calibration program. The project name is NK_M258K_LCD_TK_calibration. Don't make the wrong choice. After that, you need to connect the development board to the Touch View software. We restart the development board that has been programmed previously. After running the Touch View software on PC, choose the COM corresponding to the development board and connect it. So far, the touch key calibration environment has been established. Next, configure the sensor parameters of the touch key. First, configure the pins of the touch key. The pin configuration must correspond to the schematic of the development board. So, we need to open the schematic first and configure the channels of the touch key according to the schematic, including reference, shielding electrode, and key channels. From the figure, you can see that the first column is the name of the pin. The second column is the function type selection of the pin. Double-click to select the function of the pin. All pins here can be selected as key, slider, wheel, shield, or reference. In addition, you can also select the TK_SE pin as a shield. The third and fourth columns are to set the shielding compensation of the pin. These 2 columns are not mandatory options. If the signal strength is not enough, you can set the left and right of the key as shielding for compensation. The left and right here are not necessarily the left and right in the actual position. It is just to select 2 compensation channels for it. The number N filled in represents the pin TKN. The 4th, 5th, and 6th columns are the parameters obtained after channel calibration. Let's look at the pulse configuration. The pulse here refers to the pulse injected simultaneously into the TK reference and shielding, which controls the charging and discharging of the capacitor. Pulse width is the length of time it takes for a capacitor to charge or discharge. Pulse timers are capacitor charge and discharge times. You can adjust the sensitivity of touch keys by setting the pulse width. Therefore, shorter pulse width setting comes with poor sensitivity and less power consumption, vice versa. Pulse times are used to adjust the stability of touch key raw data. Because finger pressure on a key may vary, multiple measurements can reduce errors. Shorter time setting comes with poor raw data stability and less power consumption, vice versa. Debounce settings essentially specify the times for touch key entry and release detection. By properly setting the debounce times, you can adjust touch key stability. Shorter debounce setting comes with faster touch response time, vice versa. Next, let's talk about baseline tracking. The baseline is the CCB value when the key is not pressed. When the baseline tracking function is selected, baseline tracking each touch key automatically. The compensation rules are as follows. Baseline tracking each touch key automatically at power-up. Keeps compensating environment variation during runtime. When touch key is in the on state, trace baseline will automatically stop operating. We previously discussed configuring touch key parameters. Now let's discuss two specific applications. When the pulse width is set to 500 nanoseconds and the pulse times is set to 128 times, the touch key has good waterproof function. Support finger touch with 2 mm depth water droplet. Touch key system parameters are shown in the table and are considered to have good noise immunity. They have passed 10-volt injection test according to IEC 61000-4, 6 standard. After completing parameter configuration, we can save the parameters to the MCU. We can also read the original parameters from the MCU. 1. The store address refers to the location where our parameters are stored in the MCU. 2. Clicking Read will read the stored parameters from MCU address 0x1F800 into the software. 3. Clicking Write will save the configured parameters to MCU address 0x1F800. After configuring the parameters, it's time to calibrate the touch keys. Proper calibration is crucial for touch key performance. It will automatically adjust reference CB, CCB, and the touch threshold. For clarification, reference CB refers to the capacitor bank CB at the positive terminal of the comparator. CCB refers to the capacitor bank CCB at the positive terminal of the comparator. The touch threshold indicates that a touch key is considered pressed when the finger touch signal is greater than or equal to the threshold. Click the calibration button to pop up the touch key calibration window. Next, let's talk about the calibration window. First is the calibration option, which includes 3 buttons. Noise immunity sets the threshold for determining if a touch key has been pressed. There are 3 levels: low, medium, and high. Low indicates that the threshold is equal to 1/3 of the signal value. Medium indicates that the threshold is equal to 1/2 of the signal value. High indicates that the threshold is equal to 2/3 of the signal value. The Start button is used to begin calibration. The Write button is used to write the calibrated values to the MCU. The Load from HW button is used to read the calibration values stored in the MCU. The Export Options section contains 2 buttons. Ref Board is used to select which of the multiple pieces of engineering samples to use as a reference, and Export is used to export the calibration values to a file. Now you can begin calibrating the touch keys. Click Start to automatically calibrate CCB and reference CB. If the capacitance value is normal after calibration, press your finger on the button specified in the prompt and click OK to measure the finger touch value and set the threshold. After calibration is complete, the calibration parameters will be displayed in a table. Next, we need to export the calibration parameters. At least 3 pieces of engineering samples are required. Export the calibration parameters to a file named tk_data.c. This file can be used directly in mass production. Let's review the export steps. Click Ref Point Board to select a piece of samples as a reference. Each selected piece of samples will then be compared against the reference on a channel-by-channel basis. Select the calibration parameters to be exported. You must select at least 3 pieces. Click Export to export the calibration parameters to a file named tk_data.c. Note, if the CCB, reference CB, signal, or threshold values for any selected parameter set differ by more than 20 from the reference value, an error will be displayed during export. Next, open the production project. Here, we'll use the example program. Step 1. Select the project NK_M258KE_LCD_TK_free run. Step 2. Open the TK_data.c file in the project. Step 3. Find the calibration parameter save address. It must match the address set in TouchView. Step 4. Copy the parameters exported by touchview.exe to TK_free run project. In addition to setting parameters and calibrating the touch keys, the software also allows you to test touch key performance. Let's explain how to do it. Click the Raw Data View button on the main screen to display the test image. 2. Click Start. 3. When your finger is pressed, the signal strength will be displayed. Today, we've covered how to use the TouchView software to configure touch key parameters, calibrate, and test touch key performance. We hope this is helpful. The video is over. Welcome to Scan the Code to follow Nuvoton account and get the latest product information and event information.